In our previous lectures, we have discussed about arrays. So for this lecture, we will be discussing multidimensional arrays, which you can think of as an array of arrays. So let's dig in deeper. So an array may have a number of dimensions. So for example, we have this declaration, uh, declaration which involves declaring an array subjects with a data type int and two dimensions with sizes 3 and 4. So this is how you can visualize it. You can visualize it as having 3 rows and 4 columns. So in the previous exam discussions that um, we have introduced an array, and then an array has, you can visualize it as 1 row. But for multidimensional arrays, you can visualize it as having rows as well as columns. So for example, imagine a teacher having three subjects, and for has each of these subjects has four na sections. Okay, so you can think of the array as like that. So this is how you can formally define or declare a multidimensional array. So you specify the data type and then the name of the array as well as the length. So you can beyond the two na dimensions, you can specify for as long as many dimensions that you need. Okay, and so in this case, let's say length 1, that you have the row, and then the length 2 will be the number of columns for each row. And then if you specify another na dimension, that will be you can specify as having row and then the column, and then for that each of the cell will have another array. Okay, so the simplest form of multi-dimensional array is a two-dimensional na array. So it's a list of one-dimensional na array. So in order for us to declare a two-dimensional na integer array of length x and y, so we follow this syntax. We have the data type, the name of the array, and then the sizes of the array. So the data type can be any valid na C na data type, and then the array name can be any valid na C identifier. And again, you can think of it as a table which will have X number of rows and Y number of columns. All right. So this is how you can visualize it. So, and for example, we have an integer array A with sizes 3 and 4, where it means that we have 3 rows. So 3 rows and 4 columns. So you can visualize it like a table with 3 rows and 4 columns. All right. So we have like we have specified before, both of these indices will begin with 0. So let's say and in order for us to access the element of a multidimensional array, um, in order for us to access this element, so we refer to the index of subscript of the row as well as the column. So to access the element of A in row I and column J, we must write this. So the array name, in this case, we have the array A followed by the index of the row and followed by the column, in which each of these indices are bracketed. So the expression A of I, so the expression A of I denotes to the row I of A. So meaning row of 0, let's say A of I or A of 0, that will refer to row of 0. A of 1, that will refer to row of 1. So A of 2, that will refer to row 2. Okay? And if we write A of I of j, then that means that we are selecting j in this row, in a specific na row. So for example, in here, we have a of 0 of 0. So that means that we are accessing the element on the first row, because we have 0 here, and the element in the column na 0. So you look first on the row. You look first at the row, all right? The 0, row 0, followed by the column. So what if we want to access this element? So that refers to, you look at which row it is located. So it's located at row 1 and the column 3. Okay. So now you just have to resist temptation to write a of I comma j instead of this one. This is the correct one because the C treats the comma operator in this context. So a of I ij separated by comma is the same as a of j. All right. So let's have a more understandable example. So let's say we have a movie ratings by multiple na viewers. So we can think of it as a multi-dimensional array wherein we have an array of viewers and each na viewer will review several na movies. Okay, so each row will be a different na reviewer. So row of reviewer 1, reviewer 2, reviewer 3. Okay, but we are starting from 0. So we have reviewer 0, row 0, row 1, row 2. And then let's say we have this reviewer 1. Each of the reviewer will review 4 na movies. Okay, so the reviewer 1, and then the values in each of the cell will represent the rating that a certain viewer has assigned to a certain movie. So for example, in this cell, this in order for access this rating, this you look for the row first. So that is for the reviewed by reviewer 1 and for movie 1. Okay, and then the review of reviewer 1 to movie 1 is 4. Let's say 4 out of 10. Okay, and then this one for the rating na 6 is this has been this is a rating made by reviewer 1 or reviewer 1 to movie 2. Okay, do you understand? And then and it goes on like that. So for example, again here, rating of 0 to, so this 0 refers to the row, or in this case, since it's 0, this refers to reviewer 1. So let's look for this. And for movie 2, so that this refers to the third column. So that means that for this specific na movie, and it has a rating of 2 as specified by the viewer 1. Okay, what about this one? We have rating of 1 of 3. So meaning for reviewer 2, so you look for the row 1. So that is here, row 1. And you look for the movie 3. So this is for the column 3. So which means that for this specific na movie reviewed by reviewer 1, reviewer 2 pala, or on row 1, so the rating is 8. Okay? So now the question is, how are these multidimensional na arrays stored in computer na memory? So although we visualize two-dimensional na arrays as tables, so that's not the way they are actually stored in a computer memory. So this is how it is stored. So this is visualized like this in order for us to understand it better and visualize it better. But the memory is stores array in a row major no order. So it stores the row 0 first, followed by the row 1, and followed by the row 2. So this row 0, so which is comprised of 4 columns. So this is how it's stored in memory, and then followed by the next na row, and with its specific na column, yes, and then followed by the row 2. Okay, so now how can we initialize and store data to a multidimensional na array? Okay, so uh, it may be initialized by specifying bracketed values for each row. So for example, we have an array num with data type na integer and sizes 3 and 3. So that means you can visualize it as having 3 rows and each row having 3 columns. All right. So meaning we are expecting 9. We are expecting 9 na elements. All right. So because we have 3 na rows and then each having 3 na columns, so 3 times 3, that will be 9. So you can initialize it using this way with using this technique. So you have the first na row 516, so that will be stored in this row na 0, and each of this value will be considered as the column value of this specific na row 0, and then this next will be another bracketed na list for 63, which will be stored on row 1, and then each element of this row 1 will be considered at its column na value, and same is true for 2, 8, and 7. So the following na initialization is equivalent to the previous na example. So you have this, what essentially was done is we just removed the new line, and then we initialized it in only one line. Okay, so that this is equivalent to this part, and this is also equivalent to this. So what happened is that we have removed the braces. Okay, so how is this possible? So we know that we know that the second na dimension is 3. That means that each row will have 3 na columns. All right, so we'll have 3 na columns. So that means that the compiler will understand this one as tatlong values. This will belong to the row 1, and then this next set of values, tatlo na naman sila, so that will belong to row 2, and the next three values will belong to row 3. Okay, so since we have specified, or the compiler knows that that the second dimension is 3, or the column na size is 3, so that's why it can understand it without the braces. So this format also stores data in the array, but results in a loss of readability. Okay, so omitting the inner braces in a multidimensional array initializer can be risky, since an extra element, or even worse, a missing element, will affect the rest of the initializer. So leaving out the braces causes some compilers to produce a warning message as missing braces around initializer. Right. So these are there are also legal and invalid na legal and illegal na initializations. Okay, so these are the valid na initializations. So on the first na example, you specify both of the array na sizes. Okay, so the compiler knows the row as well as the number of columns per each na row. Now, this is also valid. So it doesn't matter if you don't specify how many rows there are, but it's important that the array knows the column na size. So because it should know how to group this specific na values. So, alam ng compiler mo na, okay, 2 pala yung size ng column. So, it will group this as, okay, 1 and 2, and then 3 and 4. Okay, so, and then, so, depending on the number of the elements that we have, that's how your compiler will determine the number of rows in your the number of rows in the multidimensional or two-dimensional array that you have specified. So meanwhile, these are the invalid na initialization. So the first invalid na initialization is you do not specify any array size at all. So as you can see, these brackets are empty, meaning you have not specified any value here. So your compiler does not know how to group this these values, right? So in other words, your compiler does not know how to store it into the memory. So, and then another is that you have specified the rows, but you have not specified the number of columns. Okay, so alam ng compiler mo yung number of rows, but it does not know the number of columns. So how should it group this number of how should it group these values? Okay, so how should it store in the memory? Kasi hindi niya alam kung paano, or paano niya malalaman kung ilang memory yung i-allot niya, kasi hindi niya alam kung ano yung number of columns. So again, one important fact is that when initializing it to the array, specifying the number of rows of the array is optional, but specifying the number of columns of the array is important and mandatory. Okay. So C provides a variety of ways to abbreviate initializers for multidimensional arrays. So, I'm sorry. If an initializer isn't large enough to fill the multidimensional array, the remaining elements are given a value of 0. So for example, the following initializer fills the first rows of A and the last row will contain A. So suppose we have an array A, and then with we have a two-dimensional array A with size 3 and 3, which means we have 3 rows and each row having 3 na columns. So we have initialized it to having the first na row having values 5, 1, and 5. So that will be considered as one row, and 4, 6, 3, that will be another row. So, but we know that we have 3 rows, diba? So, but we did not specify any value for the third row. So, what your compiler does is to fill in the remaining elements with 0. Okay. Now, if an inner list isn't long enough to fill a row, the remaining elements are initialized to 0. So we call this as jagged array. So here's an example. So we have an array D with still similar to the previous example, has a size 3 and 3. So meaning each having 3 rows and each row having 3 na columns. So we have for the first na row, we have values 5, 1, and 5. But for the next na columns, 2 and 3, we did not kulang yung elements. All right. So the second row has only specified a value for the first na column, which is 4. Similarly, for the third na row, it specified a value of 2 for the first column, but no value for the last 2 columns. So what your compiler does is to fill in this missing na values in a specific na row with 0. So again, these are called jagged arrays. And since a 2D array is a 1D array of references to 1D arrays, each of these latter na 1D array rows can have a different na length. Okay, so designated na initializers also work with multidimensional arrays. So we have discussed in our previous um, na lectures wherein you can initialize only specific na positions in the array. So for example, meron tayong 3 by 3 na 3 by 3 na multidimensional na array. So you only want to specify values for these cells. Okay? So and this this can be accessed using subscript row 0 and column 0. So we set uh, we set index in we set the value for row 0 and column 0 as 1, and then for this one, for this specific na cell, we also want to set it as 1. So and then this is in position row 1 and column 1. So we set 1 1 as also 1, and the rest will be that are not initialized will have a value of 0. Okay, so as usual, elements for which no value specified will default to 0. Okay. So now, how do we process multidimensional arrays? Yes, we can still use loops, and for loops go hand in hand with one-dimensional arrays. Nested for loops. Nested for loops naman yung ginagamit for multidimensional na arrays. Why? Because we have to loop through the row, and for each row, we have to loop through the columns.